The chorda tympani is a branch of the facial nerve that originates from the taste buds in the front of the tongue, runs through the middle ear, and carries taste messages to the brain. It joins the facial nerve, cranial nerve 7, inside the facial canal, at the level where the facial nerve exits the skull via the petrotympanic fissure. The chorda tympani is part of one of 3 cranial nerves that are involved in taste. The taste system involves a complicated feedback loop, with each nerve acting to inhibit the signals of other nerves. The chorda tympani appears to exert a particularly strong inhibitory influence on other taste nerves, as well as on pain fibers in the tongue. When the chorda tympani is damaged, its inhibitory function is disrupted, leading to less inhibited activity in the other nerves. Structure. The chorda tympani exits the cranial cavity through the internal acoustic meatus along with the facial nerve, then it travels through the middle ear, where it runs from posterior to anterior across the tympanic membrane. It passes between the malleus and the incus, on the medial surface of the neck of the malleus. The nerve continues through the petrotympanic fissure, after which it emerges from the skull into the infratemporal fossa. It soon joins the pathway of the larger lingual nerve, a branch of the mandibular nerve. The fibers of the chorda tympani travel with the lingual nerve to the submandibular ganglion. Here, the preganglionic fibers of the chorda tympani synapse with postganglionic fibers which go on to innervate the submandibular and sublingual salivary glands. Special sensory, taste, fibers also extend from the chorda tympani to the anterior 2/3 of the tongue via the lingual nerve. Function. The chorda tympani carries 2 types of nerve fibers from their origin with the facial nerve to the lingual nerve that carries them to their destinations. Special sensory fibers providing taste sensation from the anterior 2/3 of the tongue. Presynaptic parasympathetic fibers to the submandibular ganglion, providing secretomotor innervation to 2 salivary glands, the submandibular gland and sublingual gland, and to the vessels of the tongue, which when stimulated, cause a dilation of blood vessels of the tongue. Taste. There are similarities between the tastes the chorda tympani picks up in sweeteners between mice and primates, but not rats. Relating research results to humans is therefore not always consistent. Sodium chloride is detected and recognized most by the chorda tympani nerve. The recognition and responses to sodium chloride in the chorda tympani is mediated by amiloride-sensitive sodium channels. The chorda tympani has a relatively low response to quinine and varied responses to hydrochloride. The chorda tympani is less responsive to sucrose than is the greater superficial petrosal nerve. Chorda tympani transection. The chorda tympani nerve carries its information to the nucleus of the solitary tract, and shares this area with the greater superficial petrosal and glossopharyngeal nerves. When the greater superficial petrosal and glossopharyngeal nerves are cut, regardless of age, the chorda tympani nerve takes over the space in the terminal field. This takeover of space by the chorda tympani is believed to be the nerve reverting to its original state before competition and pruning. The chorda tympani, as part of the peripheral nervous system, is not as plastic in early ages. In a study done by Hosley et al. And a study done by Solers, it has been shown that when the nerve is cut at a young age, the related taste buds are not likely to grow back to full strength. In a bilateral transection of the chorda tympani in mice, the preference for sodium chloride increases compared to before the transection. Also, avoidance of higher concentrations of sodium chloride is eliminated. The amiloride-sensitive channels responsible for salt recognition and response is functional in adult rats but not neonatal rats. This explains part of the change in preference of sodium chloride after a chorda tympani transection. The chorda tympani innervates the fungiform papillae on the tongue. According to a study done by Solers et al. In 2002, when the chorda tympani has been transected early in postnatal development, some of the fungiform papillae undergo a structural change to become more filiform-like. When some of the other papillae grow back, they do so without a pore.
Please subscribe and thanks for watching.